You wake up, check your phone, and there it is. Rain at 3 p.m., wind tonight, a storm tomorrow, a cold front by the weekend. It feels so ordinary that it is easy to miss how strange it really is. Because the weather is not a train schedule. No one has already decided what it will do. The atmosphere is a huge moving system of air, heat, moisture, wind, and pressure that is constantly changing across the whole planet. And yet every day we ask an almost impossible question. What is it going to do next? So how do we actually answer that? How can anyone predict rain before it falls, track storms before they arrive, or estimate temperature and wind days in advance? And why do some forecasts feel very reliable while others seem to change every few hours? In this video, we are going to break that down simply, because weather forecasting is not guessing. It is one of the most impressive hidden infrastructure systems in everyday life, built from observation networks, radar, satellites, weather balloons, computer models, and the people trained to interpret all of it. The first thing to understand is that forecasting begins with measurement. Before anyone can predict what the atmosphere will do next, they need a picture of what the atmosphere is doing right now. That sounds obvious, but it is the foundation for everything that follows. Those observations come from many different places at once. Some come from weather stations on the ground. These measure things like temperature, pressure, humidity, wind, and precipitation. In the United States, one major network is called the Automated Surface Observing System, or ASOS. It updates observations constantly, all day and all night. Some come from the ocean. Buoys floating offshore measure wind, air temperature, water temperature, pressure, and wave conditions. That matters because a lot of weather develops or changes over the ocean before it ever reaches land. Some come from aircraft. Commercial planes can automatically send weather reports while they fly. These give forecasters useful information about wind, temperature, and pressure higher in the atmosphere, especially around airports and major flight routes. And then there are weather balloons. Twice every day, from many sites across the United States, the National Weather Service launches balloons carrying instruments called radiosondes. The word sounds technical, but the idea is simple. A radiosonde is a sensor package that rises through the atmosphere and sends back measurements of pressure, temperature, humidity, wind speed, and wind direction. That upper air information is incredibly important. Weather is not only happening at ground level. Storms, jet streams, and atmospheric instability all depend on what is happening much higher up. Then there are satellites. This is one of the biggest parts of the modern forecast system. Some satellites watch weather systems from far above and give forecasters broad views of clouds and storms. Others collect information about temperature and moisture throughout the atmosphere. One especially important system in the United States is the Joint Polar Satellite System, or JPSS. These satellites circle the Earth from pole to pole and help provide a huge amount of the data used in weather prediction. A forecast on your phone may depend heavily on satellites that keep scanning the entire planet above you. And then there is radar. Radar is what helps forecasters see precipitation and movement inside storms. In the United States, the best-known radar network is called NEXRAD, which stands for Next Generation Radar. This is important because radar does not just show where rain is, it can also show how storms are moving and, in some cases, whether winds inside a storm are rotating. That is one reason modern warnings for tornadoes and severe storms are so much better than they used to be. So by this point, forecasters have an enormous amount of information. They have ground observations, ocean observations, aircraft reports, weather balloon data, satellite data, and radar data. But all of that is still not a forecast. It is the raw material. Before forecasting can begin, that information has to be turned into a structured picture of the atmosphere as it exists right now. Meteorologists call this an analysis. In plain English, it is the best possible map of current weather conditions built from all the observations available. That analysis is what computer models start from. A weather model is a giant computer simulation of the atmosphere. It takes the current picture of the atmosphere and uses the laws of physics to calculate how air, moisture, pressure, and temperature are likely to change over time. This is where forecasting stops looking like reading clouds and starts looking like a massive science and computing problem. The atmosphere is huge, messy, and always changing. To model it, computers divide the atmosphere into many points or grid spaces and calculate what is likely to happen in each one. Then they keep stepping that whole system forward in time. That is why weather forecasting improved so much when computers became more powerful. But weather models do not give one perfect answer. This is one of the most important ideas in the whole topic. The atmosphere is chaotic. Even tiny differences in the starting picture can lead to bigger differences later. So forecasters do not usually trust one model run all by itself. They often compare many model runs and many models. That brings us to the idea of an ensemble. An ensemble is a group of model runs that are slightly different from one another. If those runs mostly agree, forecasters feel more confident. If they spread apart, confidence drops and uncertainty rises. That is why forecast maps sometimes look clean and certain, while hurricane spaghetti plots look messy. The messiness is not bad science, it is honest uncertainty. And this is also why forecasts get worse the farther out they go. The farther you move into the future, the more time there is for small differences to grow into bigger ones. That is why tomorrow's forecast is usually much better than next week's. It is also why some weather is easier to predict than others. A broad, slow-moving pressure system is often easier than the exact timing of one thunderstorm over one neighborhood. So if the models do so much, what do meteorologists actually do? A lot. Meteorologists do not just copy what a computer says. They compare observations, radar, satellite images, and different model outputs, then use training and local experience to decide what seems most realistic. That human step matters because real forecasting is not just about reading computer output. A forecaster may know that one model struggles in a certain setup. They may recognize a local terrain effect the model does not handle well. They may see from radar that a storm is strengthening faster than expected. They may decide that one possible outcome is much more likely than another. That is why forecasting is still a human job, even in the age of powerful computers. The model gives possibilities. The meteorologist turns those possibilities into a forecast people can actually use. That could mean a rain chance, a snowfall total, a hurricane track, a tornado warning, or simply the decision to bring an umbrella. And warnings are especially important. Forecasting is not only about tomorrow's temperature, it is also about deciding when the atmosphere has crossed the line into something dangerous enough to require action. Radar, observations, model guidance, and human judgment all come together in that process. So how do we actually predict the weather? We measure the atmosphere constantly. We build the best possible picture of what it looks like right now. We use computer models to simulate what may happen next. We compare multiple possible outcomes to understand uncertainty. And then meteorologists use experience, local knowledge, and real-time data to turn all of that into a forecast that ordinary people can understand and use. That is what makes weather prediction such a perfect hidden infrastructure story. Most people only see the final product, a sun icon, a number, a map, a radar loop, or a weather alert on their phone. What they do not see is the giant system behind it. Weather stations, buoys, aircraft reports, weather balloons, satellites, radar networks, computer models, forecast offices, and trained people all working together to answer one incredibly difficult question a little better every day. So the next time you check the weather, it is worth remembering what you are really looking at. Not a guess, a constantly updated scientific effort to understand the atmosphere before it gets to you. That is how we actually predict the weather, and like so many hidden systems, the better it works, the easier it is to forget how much has to happen before you ever see the forecast at all. If you enjoyed this video, make sure to like and subscribe to Hidden Infrastructure of the World. Also, comment down below what hidden infrastructure you want to see next. See you in the next video.